Robots have the benefit of being able to interact with the physical world and do things that otherwise digital information cannot. We know very clearly.
Nvidia just showed off a robot at GTC 2025 that learns by watching YouTube videos, and it's already being tested in real hospitals and farms. The robot named Blue can learn how to fold a shirt or grab a sponge just by watching it once, thanks to a new system called Newton that mimics real-world physics. Tune in because Nvidia just opened up their robot platform to the public, and what happens next might change who really does the world's work. The birth of the learning machine. The engineers at Nvidia made chips that are much faster and smarter than the old ones. They are not only for games or fancy computer work anymore. These things are made to think and react. They can run many different programs at the same time and still have room left over. That is what makes the new robot behave more like a real helper than a stiff machine stuck in one task. But when it started to sense and predict like a human, everything changed. Now, why even build robots like this? It is simple. There are not enough people to do the jobs. Stores, warehouses, farms, hospitals, they all need workers. But the number of people willing or able to work is dropping. Worldwide, there might be a shortage of about 50 million workers by the end of the decade. That is a huge gap, and factories, companies, and service centers are all feeling the pressure. Nvidia suggests that these robots may end up being paid the same as workers, not in vacation days or health insurance, but in actual cost. Maybe around $50,000 a year to operate a machine that never gets tired. A machine that does not sleep, eat, or need time off. It is not about making people jobless. It is about filling the spots no one else is around to take. And these are not just one-kind robots. There are many different ones coming. Some work in warehouses moving heavy stuff. Some are packed into cars helping them drive. Some are in hospitals helping with tasks. Some are even being tested on farms. Any place that needs work done without stopping, these machines might show up there. Imagine robots tucked into walls, working behind shelves, or rolling down factory floors. That is not a dream anymore. It is happening now. The cool part is that Nvidia is not stopping at single-task machines. These are called general-purpose robots. Instead of doing only one thing like sweeping or mopping, these can switch jobs. They can learn to do new stuff. They pick up on patterns and adapt. They understand what they see and hear in real time. That is a big deal, because before, robots had to be told exactly what to do, step by step. Now they figure things out. The robot they showed at the event was not standing still. It moved naturally. It picked things up without shaking. It responded when the world around it changed. It did not stall or break down. That smooth behavior comes from the chips inside. Those smart chips are what give the robot its brain power. Inside those chips, there is room for massive amounts of data. Billions of camera views, sound signals, and other inputs can run through at once. Warehouses are already full of cameras. Now, those cameras are not just for watching. They feed data into systems that can think and act. It is a new way of working, smart, fast, and connected. These robots can even learn by watching videos. Not special videos either, just everyday stuff online, like someone showing how to fold a shirt or clean a table. The robot watches, learns the steps, and can do it without needing someone to program each move. That is a big change. It means robots can learn like humans do. Watch, try, learn. And this way of learning saves time. Old robots needed long hours of code and tests. These ones just need good examples. They take what they see and build a plan in their head. It is not magic. It is just smart systems doing their job right. They do not forget either. What they learn sticks. Next comes what makes all this hardware actually tick. How smart chips are replacing missing hands. The hardware inside these robots is no joke. There are not just one or two chips. There are teams of chips inside. Some are for vision, some are for sound, others for movement. They split the work. One chip might handle what the eyes see. Another takes care of balance and steps. That makes the whole robot smoother, quicker, and less likely to mess up. These chips are also energy smart. They do not get too hot. They do not drain power like crazy. That is important if a robot needs to run all day long. If it is working 12 or 16 hours straight, it better not overheat or crash. These new chips were built with that in mind. There is also a brand new software system built just for these robots. Think of it like the boss inside the machine. It tells all the parts what to do. It connects the eyes to the arms, the ears to the head, and the feet to the ground. Without that software, the chips would just sit there. This system is what turns hardware into something that acts and reacts. And it is not all running alone. These robots connect with each other. They share what they learn. If one robot figures out how to stack boxes faster, it sends that knowledge to the others. Like a team sharing tips. One robot gets better, the whole group improves. That is how fast progress moves when machines can talk to each other. The companies who run factories are not waiting around. They are getting ready to bring these robots in. This is not a test or a demo. It is real, and they want it. Because if one robot can do the job of 3 people without breaks or slowdowns, that saves money and keeps things running. Robots are not some far-off idea. They are showing up now. Built with smart chips, loaded with sharp eyes and ears, packed with strong arms and legs. They are not just doing boring tasks either. They are handling tools, sorting items, carrying weight, and following what they learn. And Nvidia is making the full package. The brain, the training, the chips, the system, even the factory tools that help teach the robots what to do. It is all connected, from chips in the lab to machines on the floor. They are pushing the line between smart software and physical machines. Each piece has a purpose. Each upgrade leads to smoother, faster robots that actually help where help is missing. Factories, farms, hospitals, and warehouses are all changing. With workers hard to find, these machines are stepping in. They are not perfect, but they are getting better fast. With every update, every new chip, every new software tweak, they learn more and do more. They are built to fit into the world that already exists and to keep up with everything moving around them. That is only part of it. The way these robots learn and train is a whole story on its own. Teaching robots the human way. This robot runs on something called Omniverse, kind of like a digital world builder. It lets them create fake worlds where they can train the robot without breaking anything. Inside this Omniverse, they added something new named Cosmos. Cosmos is built to understand real-life rules like gravity, motion, and how things bump into each other. Nvidia uses Cosmos to make endless types of fake environments where the robot can learn. Not just a few dozen setups, we are talking about tens of thousands. All fake, all smart, and all ready for training. That way, Nvidia doesn't have to test the robot in the real world every time. They can train it in thousands of different fake rooms. When it goes out into the real world, it already knows what to do. Training a robot takes a crazy amount of data. It's not just about walking or picking up stuff. The robot has to understand touch, weight, balance, and how to grab things without smashing them. That's where these fake worlds help. They give the robot all kinds of learning without breaking real objects. Now comes the physics engine. Most engines like this are made for games. They look fun, but they don't really match how stuff moves or feels in real life. Nvidia needed something tighter. A tool that understands how both hard and soft things behave. How a ball bounces, how a sponge squishes, how a machine hand should move. Nvidia built a new physics tool just for this. They called it Newton. They didn't make it alone. They teamed up with 2 other big companies. One is known for making smart machines. The other makes some of the best movie tech in the world. Newton was designed to follow the laws of real-world physics as close as possible. It helps the robot learn how to move arms, fingers, and grip things. It understands pressure, angles, and force. This lets the robot know how hard to hold something. A rock and a paper towel need very different touches. Everything runs fast, no waiting around. The training works in what they call super real time. That means faster than real life. This robot can go through thousands of learning steps without any human stepping in. The robot, named Blue, has 2 full Nvidia computers packed inside. These are not regular laptops. They are made to think, learn, and react fast. Blue takes in what it sees and decides what to do right away. It has sensors for touch, motion, and feedback. Touch feedback is a big deal. That's how the robot knows what it's holding. A sponge, a wrench, a tennis ball. Each one needs a different kind of grip. Newton was made to understand that kind of variety. From hard metal to soft fabric, the robot has to respond the right way. This type of learning doesn't come from a few hours of testing. The robot runs through thousands of different setups in Cosmos. Each one teaches it how to move, stop, lift, or place something. Newton makes sure the physics is correct. Cosmos gives it the fake world to train in. The robot trains day and night inside those fake rooms, building memory for all kinds of tasks. Even better, one of the robot platforms Nvidia built, called Gruton 1, is now open to the public. That means developers and builders all over the world can take that setup, change it, and use it to build their own smart robots. It's like handing out blueprints for a robot that already knows how to learn. The brain chips running inside Blue are not just powerful. They are built to handle thinking, motion, and choices. These chips let the robot go from seeing something to doing something in seconds. Is it safe to let robots learn this fast? Drop your thoughts in the comments, smash that like button, and subscribe for more deep dives into the future of tech.